In section 32, we are modeling with regression. We're effectively taking the tools that we've learned already, linear regression and exponential regression, and applying those to context problems. The trick to this section, though, is we don't know which regression model we should use, whether it's linear or exponential. But we can figure that out by adding one additional step to the problem. So in our first situation, we have a table below representing the amount of money earned in dollars for time spent babysitting in hours. We know that the babysitting time is our input, and we're going to put inputs into list 1. We know that the money that we earn is the output. We're going to put that into list 2. What we're going to do next is go to the calculator, enter that data in, and we're going to create a scatter plot. So to enter the data in, I'm going to go to Stat and Edit. So I'm going to press Enter. I want to list or enter this stuff in. I'm going to go to the top of my list here, and I want to clear out all that old stuff. I don't want it. And then clear that out as well. And into list 1, I'm going to type in the hours. So it's 1, 2, 3. Oops. Let's go back. 2. There we go. 3, 4, 5. Doing it again. 4. Sorry. 5, 6, 7, and 8. And then to list 2, I'm going to type in the output. 5, 8, 17, 5, 28, 33, 35, and 35, and 40. All right, now that I have all that information in there, I'm going to clear out my keystroke history here. I want to see what the graph actually looks like. So I'm going to go to my stat plots and make sure that they're on. And I'm going to show you another way you can actually do that. Let's go to y equals. And you'll see here that I have some old regression equation in there. I'm going to clear that out. Now I look up at the top and plot 1 is highlighted. That tells me that my stat plots are on, and that's exactly what I want to happen. So to see this graph, I'm going to go ahead and press zoom. And I want to go to the stat zoom. So zoom stat, which is 9, and it will graph it for me. So this is my scatter plot, and it looks to me based on the data, if we only looked at this portion, I would say it's probably exponential. But the fact that it kind of levels off for a while tells me that it's probably linear data that I'm looking at. So I'm going to create a linear regression model to fit the data. So I'll go to Stat, Calculate, and option 4 is linear regression. So I'll hit Enter. And as always, when we create a regression model, we want to store it somewhere so that we can use it. It's not a matter of just creating the model. It's a matter of creating that model to answer some questions. So to do that, I go to Store Regression Equation, Alpha, Trace, and then Y1. And we go down to Calculate, and it's going to store it for me. So again, I'll write that equation down, and I can use that later to actually solve some things. Let me show you what the equation looks like in our context. Because it's the number of dollars dependent on hours, my input is actually H and not X, and my output isn't Y, it's D of H, dollars dependent on hour. So it's 5.131H plus 0.786. So going back to the equation, now we can take a look at Y equals and make sure that it's there. It is. That's good news for us. So if I take a look at the graph, that's what our graph looks like. And it looks like it's a fairly good fit for a linear regression. So at this point, I've got a couple options on how I can actually calculate the value at 15, which is what I'm asked to do next. I'm going to do this with a table because we've already talked about how do we do this on the home screen by recalling the variable. So first things first, I want to double check my table, go to second window. And starting at -2, I don't think it's going to be pretty good because I want the value at 15. So I'm going to start my table at 15. And then to get the table, do second graph. And there's our answer. So the input is 15, our output is 77.75. So working 15 hours would give you $77.75. In question 4, we want to know what's the minimum number of hours one would have to babysit to earn $100. So now we're looking at our outputs, which are the Y1s in this case, and we're looking for when that number first reaches 100. So looking at the data, it looks like right here at 103.4, that would be the first time we're above 100. That's when it's 20 hours. So our answer for that then would be 20 hours of babysitting. So again, 77, 75 for the 15, and then 20 hours to earn at least $100. In Model 2, we are going to take this data for the growth of the population of Frankfurt over several years. And this was a key piece of information in the warm-up, or not the warm-up, but in the prompt for number 1. It said let 1900 be represented by x equals 0. So that's kind of key here, that 0 for that year. So what that means then is we're going to have to change our inputs. We're not going to enter in 1900, 1920, and so on. We're going to enter in some slightly different data. We're going to enter in 0, 20, 60, 90, 100, and 110. That's the data we're entering for our input, and then our output is still going to be our population. So let's go ahead and do that, and we'll see that it is clearly an exponential model when we actually do this. So let's go back to the calculator. I am going to clear out of here, and I'm going to clear out our keystrokes. All right, go to Stat and Edit, and enter our data in. So let's clear this out first. And in list 1, 0, 20, 60, 90, 100. For some reason my zeros didn't register. There we go. Oops. And 110. Now I'll go over to my Y2 or L2, which is going to be my outputs. And let's see, 250 for 1900, 590 for 1920, 1135, oops, 35. There we go. 7180, 10,391. Type a little slower. There we go. And I messed up here. 7180. All right, there we go. And our final data point is 17,782. All right, now we've got all that data in. Again, we are going to go to y equals, make sure that our stat plots are on. They are. I'm going to clear out this old equation. And I'm going to go to zoom 9, so it's going to find a good window for us. And then based on that, it looks like the population is kind of steady for a while and then just radically jumps up. That would be an exponential function. So we'll go through and we'll do our exponential regression. Go to Stat, Calculate, and then exponential regression is option 0. And store it into Y1. So alpha trace, and calculate. And it's done that for us, so we'll go to graph. And it's taking about a year to graph, but it is graphing. So essentially what we're going to do is look at our function, and it does appear to model the data pretty well. So this is definitely an exponential function, and again, it can take a while to get that data going. So at that point, we can go ahead and set up a table to do the next parts. So we want to know the population in 2020. Well, if the population at 2010 represents year 110, the population of 2020 would represent year 120. So when I set up my table start should be 120. There we go. And let's take a look at our data table now. And then so there's my population, 20,948. And in the fourth question, I'm trying to find the population at 50,000. So I can just kind of arrow down until I get there. It's going to take a little bit of time. Again, if you're on the home screen, you can also do kind of guess and check to estimate where do you think it's going to be. And then once you get fairly close, you can check numbers nearby. We're getting pretty close to this point, and we're almost there, and right there. 144, which again, from 1900, that's 144 years, so that'd be 2044. And then in Model C, and this is something really interesting happened. I really wasn't anticipating that it would, and it did. It was really cool. We're going to go to the stat plot here. We're going to enter that data in, and we have a situation where it's the number of hours spent studying for an exam and the exam grade. So we're going to enter this data into the list 1 and list 2, as usual. So in list 1, we're going to do 2, 3, 5, 6, 7. No, 6 and 7. There we go. 8, 9, 9, and 10. Let's try that again. 10. All right, my keyboard's not registering very well. All right, and then the exam grade. So 70, 72, 85, 75, 85 again, 86, 91, and 90. All right. Now my instincts on this would be that it's linear, and I can verify that by doing the stat plot. So zoom 9. Again, it looks pretty linear. These are throwing me off a little bit, but generally it seems like it's going to fit here. So if we go to stat and calculate, there we go, lock it off, and go to linear regression, we can create the linear regression model that will fit the data. So I'm going to store that into Y1 and calculate it. But I'm also going to do something else, because I did notice when we were going through this in class that a lot of people were picking a different model, and it worked out pretty well. So when we go to stat and go down to option 0, which is exponential regression, I'm going to store that as a different variable or equation. I'm going to store that as y2. There we go. And calculate it. And then I'm going to graph both of those. And the blue line will show up as a linear model, and then the red line will be the exponential model. So when we graph that, there's our linear model. Seems to fit pretty well. And then there's our exponential model. And not a whole lot of difference there. So in that case, because we have a limited set of data points, realistically, I'd say either one would be reasonable. It's not really going to affect our data that much. So whether you do linear or exponential model, both would fit pretty well in this data. Again, we have a very small sample size. We're looking for numbers 2 to 10 and a range of 70 to 90 for the outputs. So there's really not a lot of variability. And that's going to be the key here, is that at the end of it all, we can use either one because they both seem to work pretty well. So I chose the linear model, and I got 76 for my output. And those that chose the exponential got the same thing. The only difference we had was in question number 4, based on this, what exam would grade, or how many hours would you need to spend to get this exam grade. I got 14 with my linear model. Those with exponential got 13, which is not a hugely significant difference.